All right, we're back in pre-algebra, and we're taking a look at some fractions today, fractions in the equations particularly. And to warm up, I want to think about these problems that are kind of a throwback to Unit 2 here. Okay, multiplying a whole number times a fraction. All right, and pause and see if you can come up with the answers for each of these and see if there's any insight that we can talk about afterwards. Go ahead. All right, so if you recall, you have 5 times 2/5. That's 5 over 1, right? If it has no denominator, its denominator is really over 1, 5 over 1 times 2 over 5. And remember, multiplying fractions, no problem, top times top and bottom times bottom. That becomes 10 over 5, which of course can reduce to just simply positive 2. And let's go back. Let's see, okay, 5 times 2/5. Well, let's read it the other way from right to left. What is 2/5 of 5? Well, 2/5 of 5 would just simply be 2, right? You're cutting 5 into fifths, right? And you have 2 of those. 5 into fifths is 1 times 2. What about a quarter of 8? 8 times 1/4. Well, you can also think about this way. 8 divided by 4, cut into fourths, is 2. And you have 1 of those, okay? 8 divided by 4, you're basically cross-canceling here. 8 divided by 4 is 2, times 1 is 2. All right, and what about 1/7 of 7? What is 1/7 of 7? Well, cut 7 into sevenths, that's 1, and you have 1 of those sevenths, so you just simply have 1. Those are reciprocals, so that makes perfect sense why it's 1. What about 32 times 5/8, or reading it from right to left, 5/8 of 32? Well, yes, we could do 32 over 1 times 5 over 8. Then multiplying fractions is no problem. Top times top and bottom times bottom. Or maybe look to cross cancel. But let's think about this. Okay, 32 is divisible by 8. If I split 32 into eighths, that would be 4, right? Each eighth would represent 4 whole. So 32 divided by 8 is 4, and you have 5 of those. So 5/8 of 32 will be 20. Okay? 5/8 of 32 will be 20. And if you noticed, every single one of these warm-up problems, the denominator went into the whole number on the outside. The denominator went into the whole number on the outside. Let's keep that in mind as we go on to the lesson for today. I'm going to skip the rest of these equations. So if your equation has a fraction in it, you're just going to have to solve using your same old order of operations. Remember that you're going to need a common denominator here. Subtract the 1/4 from both sides. Okay, and then y is equal to 12/20. Subtract 5/20, and your answer should work out to be y is equal to 7/20. It's the same process. We're just going to have to deal with those fractions. Remember, when you're adding and subtracting, you need a common denominator. When you're multiplying, you multiply the numerators and the denominators respectively. And when you're dividing, you're going to have to copy, change, flip, multiply with the reciprocal of the divisor. Speaking of that, you have a multiplier. How am I going to undo it? I'm going to have to divide by 3/8, right? So when you divide by 3/8 on both sides, this is where we will have to copy, change, flip. We're going to have to multiply 1/2 times the reciprocal, 8/3, to get what appears to be 8 over 6, or I can just simply cross cancel and make this solution 4/3. Or 1 1/3 is absolutely acceptable too. All right, no big deal there, right? But if I reverse the tape here, we can make our lives a little easier even on this one, and I think we've gone over this already this unit, right? In a one-step equation where the coefficient is a fraction, why don't you just go ahead and multiply by the reciprocal instead of making that ugly complex thing. Multiply the reciprocal, and we're going to end up with the same thing. But if you notice, the 3's will cross cancel, the 8's will cross cancel. They are multiplicative inverses, and we end up with 8 over 6, which reduces to 4/3. Again, on the other side, x is isolated. We're good to go, moving on with our lives, right? What about if we have all these 2's on the bottom? 1/2 n, take away a half results in 5/2. Okay, well, let's go ahead and add 1/2 to both sides. add 1/2 to both sides, and I end up with 1/2 n equals, we already have a common denominator, that's convenient, 6/2, and you might want to say that 6/2 is also 3, right? But we don't need to. Now we can multiply by 2 over 1 on the other side. And if you notice, my 2's will cross cancel here. 1/2 and its reciprocal, 2 over 1 will cross cancel there. And I'm left with simply 6. N is equal to 6. Let's plug it back in just to be sure. Half of 6 is 3. Take away 1/2 should be 2.5 or something equivalent. And we have something equivalent on the other side, and that is 5/2. It checks out. Great. Okay. Practice this one. Two-step equations with fractions. See if we get the same answer. Pause it, go. Okay. And hopefully you subtracted 4 from both sides and multiplied by 5/2 to undo the 2/5. The reciprocal is your friend. And you end up with 30 over 2, which is n is equal to 15. Okay? And n is equal to 15. But what if I was not really into fractions? I'm not really a fan of those, or the fractions got more complicated. There's an alternate method, just like we did with decimals the other day. An alternate method of solving fraction equations is to multiply through the equation by a common denominator. If you look at all the denominators and find some common multiple or common denominator, this means that we can distribute that number, that common denominator, to every term, whether it is a fraction or not. Let's get a feel for what this looks like. So remember those big giant parentheses that I used for the decimal equation? Well, we're going to break those out again. If I look at these denominators, I have a denominator of 2, a denominator of 2, and another denominator of 2. This one could not be easier. The common denominator is already there for us, is 2, the least common denominator. It doesn't have to be the least common denominator. It could really be any common denominator will work, right? And we're going to break out those giant parentheses and distribute to the equation. So when I do that, it looks something like this. I put it in parentheses. Okay, I put the whole thing in parentheses, and I multiply through by 2. Let's see what happens, okay? I'm going to do this as 2 divided by 2 is 1. 2 cut in 2 is 1. N times 1 is just simply n. What is 3 over 2 times 2? Well, the 2's will cross cancel. They're going to cancel out. 2 divided by 2 is 1 times the top. 3 is 3. 2 divided by 2 is, once again, 1 times the top is -3. And now I have just simply a one-step equation to solve. Let's get an example here. I have denominators 2, 5, and 10. What would be the common denominator, the LCD, to multiply through by? 2, 5, and 10. Well, hopefully you're thinking, yeah, they all go into 10. So the common denominator in this case would be 10. Let's put it all in big parentheses and multiply by 10. Okay, just like we did with the decimals the other day. Except these ones aren't decimals, they're fractions. So we have to go, okay, 10 times n over 2. Well, instead of making this 10n over 2 and then reducing, let's kind of do it the opposite way. Let's go 10 divided by the bottom is 5. Now we'll say 10 split into halves is 5/2. We'll multiply times the top. And my new coefficient should be 5n. All right, I've distributed to the first term. Now let's distribute to the second one. 10 divided by 5 is 2 times the top is 4. So 2/5 of 10 is 4. Equal sign comes across, comes down, excuse me. And then 10 divided by 10 is 1, and this one looks like the last one, where I just have to make it -3. And voila, I have taken out all of the fractions from the equation before I've started to solve. Okay, that might be advantageous if you're trying to keep your equation nice and neat. Okay, and yeah, this one's not going to work out evenly, but at the very least, all of my math and my inverse operations require no fractions at all, -7/5 or -1 2/5 would be the solutions there. Let's do another one. The LCD In this particular case, the lowest common denominator between 7 and 14 would be 14. 7 goes into 14. Break out your giant parentheses. Let's multiply 14 times the whole equation. And remember, everybody gets a 14 because you're distributing, or you're utilizing the distributive property. 4 times 2x is 28x. 14 times 3/7. Well, 3/7 of 14. Once again, if you're not good with that mentally, just by doing 3/7 times 14, let's divide by the bottom. 14 divided by 7 is 2 times the top is 6. And once again, I picked out 14. I was the one that chose the number 14, right? And the reason I did that is because I knew it was going to cancel out all of my denominators. And then 14 times 17 fourteenths, well, 14 divided by 14 is 1 times the top, 17. And we're good to go, right? Without doing any other fraction work, now I can solve an equation. And this is a pretty basic one like we were working on the first day of this unit. I'm going to have to subtract 6 from both sides. I find that 28x must be equivalent to 11. Divide by 28. And it's not the prettiest of answers, but 11/28 is an answer. And I didn't have to do any fraction work to find the 11/28. Try this one on your own. Let's see if we get the same thing. Okay, and we're back. I chose to multiply through by 6. Hopefully you did too. Or something equivalent, even 12 or 18 would work as well. But you don't even have to go that big because 2, 3, and 6 all go into 6. When you multiply through, you have negative 3n minus 4 is 5. Nice, easy two-step equation now. Add 4 and divide by negative 3, and this one worked out to a whole number answer. This is one what I would call your choice, right? Your choice. Why would I call it your choice, whether you multiply through or not? Well, n is already by itself. This is a one-step equation. You would not be at fault if you just said, you know what, I just want to add 3/5 to both sides, make my common denominator, and move on with my life because I already know how to do that. That would be completely logical. There is no wrong way to get the right answer, but sometimes there's some more effective ways, and n is going to be 47 over 45 here. How about if I chose to multiply through? In this particular case, I would multiply through by the number 45 because the common denominator between 5 and 9 would just simply be their product. So the new equation, if I chose to multiply through, would be 45n minus 45 divided by 5 is 9 times 3 minus 27 is equal to 20 on the other side. 45 divided by 9 is 5 times the 4 is 20. All right, and I would add my 27. 45n is equal to 47, and I think you see where this is going. We end up with the same exact solution, right? So that's where it's your choice. If you wanted to multiply through and you're really comfortable with that, that's great. It turns into a two-step equation. The one-step equation is just one inverse operation, but then you got to make a common denominator on the other side. So it's kind of your choice. Last one, let's see if we get the same answer on this one. Pause it, do it. And if you notice, I multiplied through by 30, and it turned them all into whole numbers, and then solving your two-step equation ended up with, once again, not a very nice solution, but it's 35 over 36, and I'm going to move on with my life, and that is good enough for me. Check it. Ask me questions. See ya. With